Okay, welcome back for more drawing fun. So, moving on to the 2019 question, C3. I've just gone and set this thing up. Again, I'm kind of assuming that most of you are probably okay with a setup. A few little tricky things in this question, really just from the point of view of figuring out kind of what point lines up with which. Not so much a thing in the front elevation and plan. You're given all your different heights. I've indexed some stuff here. So on surface C, they are showing you that it started out as a triangular surface. So what I've called here 1, 5, 4, 1, 4, 5, whatever you want to call it. In the plan, that's an edge view. 1, 4, 5. Okay. I can see that that triangular surface is actually standing vertically up off the page. Okay, or up off the horizontal plane, because it appears as an edge view here. Okay, so that top point 1 is located there. Other than that, different heights are given for these points. To find the cutoff points, I've just dropped point 2 and 3 down to give me these points in the plan. Don't think it's going to cause much of an issue. Over here on the in view, again, just the usual, projected the points across from the plan over to the edge of the plan, up at 45 degrees. All my points that are on the ground, 6, 4, 5, are still on the ground. 6, 4, 5 at the back of the object. 5 joining up to 1, 5 joining up to 1. Okay, 1 is there, cross 45 degrees straight up. I haven't found it that way. I actually just found it by finding the point 3, joining it back to 4, find the point 2 over, and it's there up, and joining it back to 5 and also back to 3. Okay, dotted or hidden detail because that's surface C, which is there. I didn't shade it in blue the same as this because it's technically hidden by surface A and surface B, but that is that surface there at the back. Okay, again, look through it. If there's something in particular you're stuck on, let me know. So after that, first thing they ask you is draw the given elevation. Yeah, okay, we've just talked about that. Determine the dihedral angle between surfaces A and B. Surface A, in the front elevation, surface A is appearing as an edge view. Okay, why does that happen? It happens because if you look at the base edge of A, it's a vertical line, which means here it's a point view, true length, point view, and that gives me an edge view because I'm looking along a true length line on the surface of A, which gives me an edge view. Okay, surface B is here. The dihedral angle between A and B, I need the line of intersection. So that line of intersection is 7, 6. There it is there. What I would do is I would go and create a triangular surface on surface A. So from 7 down as far as there. Okay, and on B maybe from 7 down as far as some random point, we'll say there. Okay, there's a triangular surface on surface B. There's one on surface A. Okay, in front elevation, I would take that point, bring it back up. It's on the ground. It's joining as far as point 7. Bring it from the ground as far as point 7. And there's that triangle. So that triangle there is on surface B. There's the same triangle on surface B. Okay, there's my triangle on surface A, down as far as there, back to here. Okay, line of intersection, look perpendicular to the line of intersection. See there's a true length, look along the true length line, get your dihedral angle. Okay, again, I'm going to assume everyone's okay with that, so I'm going to leave that alone. Again, as I said before, if you're stuck on that, go back to my video on finding the dihedral angle, and that should help you out. Okay, so next part of the question, part C, determine the true shape of the vertical surface C and the true shape of the inclined surface B. So, as I said already, this line, because it's an edge view, so there's our triangular surface, even though it has been cut, it's a truncated surface. All right, but I still left in that point 1 just so you can see where it was originally. So the surface itself is actually 2, 3, 4, 5, surface C. In the plan, 2, 3, 4, 5. Okay, this is an edge view. So remember, the easiest thing for us to do with any of these surfaces is to take them and fold them down flat onto the ground. So the T-square up there. So looking at that at the moment, this is essentially sitting, okay, like that. It's a vertical surface, so it's an edge view. Okay. Because the edge 4, 5 is a horizontal line in front elevation, that means the edge 4, 5 is a true length in plan. Because the true length in plan, I can use that as a hinge edge. So I'm basically going to take that surface, which is sitting like that, and I'm going to fold it about the edge 4, 5 flat onto the ground like that, and I'll see its true shape. Now, because this is an edge view here, and because it's a vertical surface, and they do mention that on the question, these heights up as far as 3, up as far as 2, and even up as far as the original point 1, if you want to use that, they're going to be actual true heights. So H1, H2, and the other one, this orange height, I haven't called it anything. That's an actual height. Okay, so I can use those heights, either the one orange one, or the purple one H1, or the green one H2. I can use them when I fold the object out. Okay, so remember our normal rules. Folding out the object, it's going to, all the points are going to move perpendicular to the hinge edge. Okay, so there's my hinge. So the points I want to move are, okay, point 2 and point 3. Now, I can also, just to show you, I can do this by taking point 1, the very top point, out there as well. Okay, points 4 and 5 are on the ground, they're not going anyplace. Easiest way to do this is to take a height for the point 1, the very top of that triangular surface before it was cut. So take a height for point 1, which I think was 60 millimeters. Okay, take a height for that, bring it out along the line from 1 and mark it there. Okay, so that essentially is where that point 1 would be if it wasn't cut off. Point 1 is joined back to 4 and point 1 is joined back to 5. So join point 1 back like that. The line coming out at 90 degrees from point 3 when I fold this flat, that's actually going to give me the location for point 3. Okay, so 3 is right there. Point 1 joins as far as point 5. So point 1 back as far as 5. Okay, where it hits the line coming out from 2, which is there, that's the bit that's heavy from there back as far as 5. Okay, and 2 joins as far as 3. So 2 will still join as far as 3. Okay, now, as I said, the height I used for this was the full height, that orange height, out as far as point 1. So this is what I marked in. That height there. Okay, but the height up as far as 3, that purple height, that will still be the same there. And the height, the green height up as far as 2, that will still be the same height there if I wanted to mark it on that way either. So H1 is there. Okay. So you have 2 options for that, as I said, whichever one you want to go with. Okay, so the other one is a little bit trickier, but still the same idea. So for surface B, you're going to do the same thing again. We're going to take the surface, edge 6, 4, horizontal in front elevation, therefore it's a true length in the plan. Okay, the surface is sitting some way like that. We're going to hinge it back out this way. Okay, unlike this surface, because this is at an angle in front elevation, I can't take the height for 7 or the height for 3. Okay, because they are folded out this way. Okay, so it's a little bit different. So the easiest thing to do in this case is to get an edge view and rotate it flat onto the ground. All right, so let's say we take an edge view out. I'm actually going to bring it back down to the right hand side just from a space point of view. So I'm looking along, essentially along that base edge there. Okay, and the base edge is a true length line. It's on the surface, so when I look along that true length line, I'm going to see an edge view of the surface. So I'm going to set up my XY perpendicular to that. Okay, so that is my X1, Y1. Okay, the point 6 and 4 are on the ground. 6 and 4, they're on the ground. I'm going to take up one other point on the surface. So I'm going to take the highest point, 7. I'll go this way just so we have enough length in the set square. So from point 7, parallel to that, check it out. Okay, and again, I'm going to go back and take my height here for 7, which is 60. Going to mark it up along this. Okay, and that gives me 0.7. So 0.7 is joined back as far as the base. There's an edge view of that surface. Okay, if I want, I can bring out 0.3 as well. Sorry, parallel to this edge. So if I want to bring out 0.3, then we'll go out along there. 0.3 is located at that point. Okay. And that height up there should be the same as that height up there. Okay, the purple height. All right. So my edge view, I'm going to take this edge view, I'm going to rotate it onto the horizontal plane, onto the ground, which is the X1, Y1 line. So I'm going to take this, and it is just about going to fit on the page. So I'm bringing down 7. I'll also bring down 0.3. So 3 is going to rotate onto the ground there like that. Okay. So 0.3 is rotated onto the ground at that location. 0.7 is rotated onto the ground at that location. Just extend out this XY. All right. Project them back at the same angle they came out at. So the usual rules apply. And remember what's happening, we're just folding this shape or surface onto the ground. 3 and 7. Okay, projected back. And then finally I need to bring out my points perpendicular, because remember they're going to move perpendicular to the hinge edge. Okay, so 0.3 perpendicular to the fold edge or the hinge edge, it's going to come out as far as that location in line with that 3 there. There's 0.3. Okay, 0.7, I think I just have to move a little bit to get 7 in. Okay, so 0.7 is coming out at 90 degrees this way. Okay, so out of 90 degrees, back up along here, there's 0.7. Okay, 0.7 joins to 6, so I'm just going to join them back in the exact same order. So 7 back to 6, 7 joins to 3, and 3 finally joins back as far as 4. And then that's going to be the true shape of that surface. Okay, because if it's flat on the ground, we're looking down at it at 90 degrees. Okay, and hopefully that makes sense. I realize that some of these curved lines here, those rotated lines, are missing a little bit off the bottom of the video, but you get the idea. They've gone as far as that XY line. Okay, and then brought back 90 degrees to it. All right, so that's finding the true shape of surface C and the true shape of surface B. Okay, so best thing to do, have a look through it, see how you get on with it. If there's something in particular you're stuck on, let me know and I'll try and sort it out. And hope this helps. Okay, thanks for watching.